Hello, in this lecture we'll find out the maximum area of a rectangle that is inside a triangle. In the drawing we have triangle ABC. Inside this triangle ABC we have this rectangle PQST, and our mission is to find out the maximum area of this rectangle PQST. In addition, we know that side AB of rectangle ABC equals to 10 units in its length, side AC equals to 17 units in its length, and this is side BC of rectangle ABC that is equals to 21 units in its length. I repeat again that our mission is to find out the maximum area of this rectangle PQST. So in the first step, we will do a construction. That is to say, from point A, we draw perpendicular on PQ. Again, from point A, we draw perpendicular on PQ. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and side PQ as M. In the next step, we'll extend the perpendicular AM by a straight line until it touches side BC of triangle ABC. And we define the touching point of the extended perpendicular AM with side BC, this point, as point N. When doing this construction, we actually created here those two angles. They are defined as corresponding angles, and they are located between the parallel lines PQ and BC. And we have the rule that corresponding angles between parallel lines are equal to each other. So those two angles are equal to each other, but this angle equals to 90 degrees according to our construction, therefore this angle must be also equal to 90 degrees in size. Likewise, those two angles are also defined as corresponding angles, and they are located between the same two parallel lines PQ and BC, and therefore they are equal to each other. But this angle equals to 90 degrees according to our construction, therefore this angle must be also equal to 90 degrees. In the next step, we define the length of this line segment BN as x. So what is the length of line segment NC? From the drawing it is very easy to see that NC equals to BC minus BN. Again, BC minus BN equals to NC. So I write it down. NC equals to BC minus BN. So NC equals to BC, that is 21 units according to what is given in the question, minus BN equals to x according to our definition. So in total actually found out that NC equals to 21 minus x. NC equals to 21 minus x. So I write it down. NC equals to 21 minus x units in its length. In the next step, I will copy this right triangle triangle A and B in a new page and we'll implement on this right triangle A and B the Pythagoras theorem. Here by PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse AB of the right triangle A and B equals to 10 units in its length, according to what is given as the question. And B, side A and B equals to x units in its length, according to our definition. So actually, this is the right triangle A and B that according to the original drawing. This right triangle A and B according to the Pythagoras theorem, AB squared equals to NB squared plus AN squared. We'll subtract NB squared from this equation and we get that AN squared according to this equation 1 equals to AB squared minus NB squared. AN is the missing side, so we leave it as it is, so AN squared equals to AB squared. AB is 10, therefore AB squared is 10 squared, that is 100 minus NB squared. NB is x, therefore NB squared is x squared. So in conclusion, we shall conclude that according to equation 1, AN squared equals to 100 minus x squared. In the next step, I will copy this right triangle A and C in a new page and we will implement the Pythagoras theorem on this right triangle A and C. Here by PT is the abbreviation for Pythagoras theorem. Side NC equals to 21 minus x units in its length. And the hypotenuse AC equals to 17 units in its length, according to what is given in the question. So actually, this is the right triangle A and C that I copied from the original drawing. This right triangle A and C, according to the Pythagoras theorem, AC square equals to AN square plus NC square. So here we subtract NC square from this equation, equation 2. And you get that according to this equation 2, AN square equals to AC square minus NC square. So AN square equals to AC square. AC is 17, therefore AC square is 17 square. That is 289 minus AC square, minus NC square. NC is 21 over minus x, therefore NC square is 21 minus x square. So according to equation 2, we actually found out that AN square equals to 289 minus 21 minus x square. This is according to equation 2, and according to equation 1, we already found out that AN square equals to 100 minus x square. So here we have two different equations for the value of AN square. Therefore, we get equation 3, which says that AN square, according to equation 1, must be equal to AN square, according to equation 2. So AN square, according to equation 1, equals to 100 minus x square, and it must be equal to AN square according to equation 2. AN square according to equation 2 is 289 minus 21 minus x square. So according to equation 3, we can find out that 100 minus x square equals to 289 minus 21 minus x square. So here we open the brackets of this expression 21 minus x square, and we get that according to this equation 3, 100 minus x square equals to 289 minus, and here we have 21 minus x square. 21 minus x square equals to 441 plus x square minus 2 times 21 times x is minus 42x. Okay, according to equation 3, we found out that one hundred plus x square equals to 289, and we have here minus before the brackets. We'll open the brackets here, and we get that this expression will be equal to minus 441 after we open the brackets, and here we have minus x square, and here we have minus times minus is plus. Minus 42x equals to plus 42x. So in conclusion, according to equation 3, we actually found out that 100 minus x squared equals to 289 minus 441 minus x squared plus 42x. So here we have minus x squared on both sides of this equation first, so x squared minus x squared will get cancelled. And after we cancel minus x squared, in this side of equation 1, we left on equation 3, in this side of equation 3, we left only with 100. And it is equal to the other side of equation 3, we have 289 minus 441 plus 42x. So here we relate 441 to this equation 3, and we get that according to this equation 3, 100 plus 441 is 541, and it equals to 289 plus 42x. So here we subtract 289 from this equation 3, and we get, according to this equation 3, we have here 541 plus 289 is 252 equals to 42x. So here we divide this equation 3 by 42. And finally we get that according to this equation 3, x equals to 252 over 42 equals to 6. So we found out that x equals to 6 units in its length. So actually, this is line segment BN is equal to x, and x equals to 6. This is line segment NC, that's equal to 21 minus x. As x is 6, therefore it is 21 minus 6, that is 15. In the next step, we return to equation 1. Actually, according to equation 1, we found out that an squared equals to 100 minus x squared. But we just right now found out that x equals to 6, therefore x squared is 6 squared, that is 36. So therefore here we get that an squared equals to 100 minus x squared, and x squared is 36. So an squared equals to 100 minus 36, that is 64. An squared equals to 64. According to equation 1, we take out all of this equation, and we get that according to this equation 1, an equals to the square root of 64, that actually equals to 8. So an equals to 8 units in its length. I write it down. Here, this is actually line segment AN or side AN, that is equals to 8 units in its length. So I write it down here, AN equals to 8 units in its length. In the next step, we define the width of this rectangle PQST, the width QS is B. So QS equals to B according to our definition. That is the width of this rectangle PQST. And we define the length, that is PQ, of this rectangle PQST as A. Again, the length PQ equals to A according to our definition, and the width QS equals to B, also according to our definition, of this rectangle PQST. it is given as actually we know that PQST is a rectangle, and therefore all the angles inside the rectangle are right angles. Therefore, this angle is a right angle, and this angle is also a right angle. There are 2 out of the 4 angles inside rectangle PQST, therefore they are equal to 90 degrees in their sizes. In the next step, we will focus on this quadrilateral, this small quadrilateral, MQSN. This quadrilateral MQSN. Inside this small quadrilateral MQSN, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this 4 facing angle, in total they must be equal to 360 degrees. According to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this 4 facing angle must be equal to 90 degrees in its size. So inside the small quadrilateral MQSN, we have 4 right angles, and according to rule 6, any quadrilateral that has 4 right angles must be at least a rectangle, not a square. So we relate to this small quadrilateral MQSN as a rectangle, because it has 4 right angles. But we also know that the opposite sides of the rectangle are equal to each other. So in the small rectangle MQSN, side QS must be equal to the opposite side MN. But QS is B, therefore MN must be also equal to B. So what is the length of this line segment AM? From the drawing, it is very easy to see that AM equals to AN minus NM. AN equals to AM equals to AN minus MN. So I write it down. Repeat again. AM equals to AN minus MN. So I write it down. AM equals to AN minus MN. So AM equals to AN, that is 8. Here AN equals to 8. Minus MN, we just right now found out that MN equals to B. So in total, AM equals to 8 minus B. AM equals to 8 minus B. This side AM, or line segment AM, equals to 8 minus B units in its length. Okay. Those 2 angles, those 2 angles are defined as corresponding angles, and they are located between the parallel lines PQ and BC, and therefore they are equal to each other according to the rule that corresponding angles between parallel lines are equal to each other. So those 2 angles are equal to each other. So if we define the size of this angle BCA, this angle as alpha, then this angle also must equal to alpha because they are equal to each other. Likewise, those 2 angles, they are also defined corresponding angles, and they are located between the same parallel lines PQ and BC, and therefore they are equal to each other according to the same rule that corresponding angles between parallel lines are equal to each other. So if we define the size of this angle as beta, then this angle must be also equal to beta, because they are equal to each other. Okay, so in the next step, we'll prove that the big triangle ABC is similar to this small triangle AQP. So, why the big triangle ABC is similar to this small triangle AQP? First of all, those triangles are both equal to alpha, and therefore they are equal to each other. In addition, those triangles they are both equal to beta, and therefore they are equal to each other. And finally, this is angle A. It is a common angle that belongs to both triangles. So angle A equal to itself as a common angle that belongs to both triangles. So I shall prove that all the triangles of the big triangle ABC are correspondingly equal to all the triangles of this small triangle AQP. And therefore, those two triangles are similar to each other according to angle similarity rule. So I write it down. Actually found out that the big triangle ABC is similar. This is the sign of similar to the small triangle APQ. According to angle similarity rule. Actually, whenever two triangles are similar to each other, then the ratio between their heights must be equal to the ratio between their sides. Or in other words, whenever two triangles are similar to each other, the ratio between their corresponding heights must be equal to the ratio between their corresponding sides. Therefore, according to what I mentioned, we will get that the height AEM in the small triangle APQ over the height AN in the big triangle ABC is equal to side PQ of the small triangle APQ over side BC of the big triangle ABC. So this equation 1 means that the ratio between the heights of the two similar triangles ABC and APQ must be equal to the ratio between the corresponding sides of the two similar triangles ABC and PCQ. Okay, AM over AN equals to PQ over BC. AN equals to 8 minus B over AN equals to 8, and it is equals to PQ equals to A according to our definition, over BC equals to 21 according to what is given us in the question. So in conclusion, according to equation 1, we found out that 8 minus B over 8 equals to A over 21. Here we first multiply this equation 1. And we get that according to this equation 1, 8 times A equals to 21 times 8 minus B. So here we divide this equation 1 by 8, and we get that according to this equation 1, A equals to 21 over 8 times 8 minus B. So here we open the brackets on this side of this equation 1, and we get that according to this equation 1, A equals to, here we have 21 over 8 times 8 is 21, and here we have minus 21 over 8 times minus B equals to minus 21B over 8. So if we found out that according to equation 1, A equals to 21 minus 21 over 8 times B. So here we multiply this equation 1 by B, and we get that according to this equation 1, A times B equals to 21B, and minus 21B over 8 times B is minus 21B squared over 8. So what is A times B? A is the length of this rectangle PQST, and B is the width. The length times the width is the area of this rectangle PQST. So in this side of the equation we have the area of rectangle PQST equals to 21B minus 21B squared over 8. So according to equation 1, we have the area of rectangle PQST in function of the width B. B is the independent variable, and the area that is A times B is the dependent variable, because once you pick the value of B, the area will be determined by the value of B. Therefore, the area is the dependent variable, and the width B is the independent variable. So, according to equation 1, the area of rectangle PQST equals to 21B minus 21B squared over 8. And our mission is to find out the maximum area of this rectangle PQST. Or in other words, our mission is to find out the maximum value of the dependent variable A times B, that is the area of rectangle PQST. Or we have to find out for which B the value of A times B will be maximum. Okay, repeat again, we have to find out for which B the area of rectangle PQST, that is actually A times B, will be in its maximum value. So in order to find out what is the maximum value of the area that is A times B, we have to differentiate this function area of rectangle PQST and equate its derivative to 0. So by differentiating this function area and equating its derivative to 0, we get the extreme point of this function area of rectangle PQST, and then we have to verify that the extreme point that we found is indeed maximum extreme point and not minimum extreme point. Okay, so we start with the first step. In the first step, we will differentiate this function area of rectangle PQST. So we take the derivative of this function area of rectangle PQST. Here D is the relation from derivative, so we have to take the derivative of the function area. That's actually 21b minus 21b squared over 8. And we take the derivative of this function area according to the independent variable b. So it is db. Again, db means that we take the derivative of this expression according to the independent variable b. And we have to equate this derivative to 0 in order to find extreme points of this function area of rectangle PQST. So, what is, here it is 21b, what is the derivative of 21b? Actually we know that the derivative of b is 1, therefore in total the derivative of 21b will be equal to 21 times 1, that is 21. And what is the derivative of this expression minus 21b squared over 8? Actually we know that the derivative of b squared is 2b, and therefore in total the derivative of this expression will be equal to minus 21 over 8 times 2b, and it is equal to 0. So we found out that the derivative of this function area 21b minus 21b squared over 8 equals to 21 minus 21 over 8 times 2b, and it is equal to 0. So here we take 21 as a common factor out of those two expressions, and we get that so 21 is taken out as a common factor. What is left from 21 after we took away 21 as a common factor? What is left? It is actually 1. And what is left from this expression minus 21 times 2b over 8 after we took away 21 as a common factor? What is left? It is actually minus 2b over 8. And it is equal to 0. So actually, according to equation 2, we found out that (21) times 1 minus 2b over 8 equals to 0. So here we divide this equation 2 by 21, and we get that according to this equation 2, 21 over 21 is 1, so in this side of equation 2 we left only with 1 minus 2b over 8. The other side of equation 1 we have 0 over 21 is 0. So in conclusion, actually found out that according to equation 2, 1 minus 2b over 8 equals to 0. Here we will add 2b over 8 to this equation 2. And you get that according to this equation 2, 1 equals to 2b over 8. So here we divide both the numerator and the denominator of this expression by 2. And you get that according to this equation 2, 1 equals to 2b over 2 is b, and 8 over 2 is 4. So according to equation 1, we actually found out that 1 equals to b over 4. Here we will multiply this equation 2 by 4. And finally we get that according to equation 2, b equals to 4 units. So actually we found out that the extreme point of the function area the extreme point of this function area a times b equals to 21b minus 21b squared over 8. The extreme point is b equals to 4. The extreme point is b equals to 4. Now we have to verify that the extreme point b equals to 4 is indeed maximum extreme point and not minimum extreme point. And we will do it by drawing the graph of the function area of this rectangle PQST. That is to say, we will draw this graph. A times B is the area of rectangle PQST, and the area equals to 21b minus 21b squared over 8. Actually, I already drew the function area of rectangle PQST. Hopefully, this is the graph of the function area of rectangle PQST. This graph is the area of rectangle PQST as function of b. b is the independent variable and it is located in the x-axis here, and the dependent variable, that is the area, that is a times b, is located in the y-axis. Okay, so here you can see from the graph that when b equals to 4, here the width b is located in the x-axis. When b equals to 4 units, then the area is here in its maximum value. Okay, the area is a little bit bigger, greater than 40 square units. So actually, by drawing this graph, we actually verified that the extreme point b equals to 4 is indeed maximum extreme point and not minimum extreme point. So the only thing that is left to do is to put the value of b is equal to 4 inside the function area in order to find out exactly what is the maximum area of rectangle PQST when b equals to 4 units, when the width of rectangle PQST equals to 4 units. Again, the area function is a times b, that is the area of rectangle PQST, and it equals to 21 times b minus 21 over 8 times b squared. We just have to substitute b by 4 in this function area of rectangle PQST. We'll do it now. We get the maximum area of rectangle PQST will be equal to 21 times b. b is 4, so substitute b by 4. So it is 21 times 4 minus 21 over 8 times b squared. b is 4, therefore b squared is 4 squared, that is 16. So the maximum area of rectangle PQST will be equal to 21 times 4 is 84, minus, here in this expression we have 16 over 8 is 2, and 2 times minus 21 is minus 42. So in total, this expression equals to minus 42. So there, the maximum area of rectangle PQST equals to 84 minus 42, that is 42. So the maximum area of rectangle PQST equals to 42 square units. and that is the answer to the question. In the next step, we'll find out what is the length of rectangle PQST. We know that the width B is 4. Again, the width B is 4 units. So what is the length A? Actually we have equation 1 for A. A equals to 21 minus 21 over 8 times B. We just have to substitute B by 4, and we get that A equals to 21 minus 21 over 8 times B, and B is 4. So it is equals to 21 minus, here we divide both the numerator and the denominator of this expression by 4. 4 over 4 is 1, so in the numerator we left only with minus 21 divided by 8. 8 over 4 is 2. So the length A equals to 21 minus 21 over 2. Minus 21 over 2 is minus 10.5. So the length is 21 minus 10.5, that is 10.5. So if we found out that the length of rectangle PQST when the width B equals to 4, then the length A equals to 10.5 units. You can see that A times B, that is the area of rectangle PQST, equals to 10.5 times 4, that is 42 square units. So in conclusion, we found out that the maximum area of this rectangle PQST is equal to 42 square units. So in the next step, I will summarize the lecture. In this lecture, we found out the maximum area of this rectangle PQST that is located inside the big triangle ABC. In addition, we know that side AB of triangle ABC equals to 10 units in itself, side AC equals to 17 units in itself, and finally side BC equals to 21 units in itself. Our mission is to find out the maximum area of this rectangle PQST. So in the first step, we did a construction, that is to say from point A, we drew perpendicular on PQ. So this again equals to 90 degrees, and this again also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A inside PQ, this point SM. In the next step, we extended the perpendicular AM by straight line until it touches side BC of triangle ABC. And we define the extended this point, that is the extended point of the extended, we define this point, that is the point of the extended perpendicular AM and this side BC of triangle ABC, this point SN. By doing this construction, we can here those two angles. Those two angles are defined as corresponding angles and are located between the parallel lines PQ and BC, and therefore they are equal to each other. But this angle equals to 90 degrees according to our construction, therefore this angle must be also equal to 90 degrees. Likewise, we have those two angles. They are also defined as corresponding angles and are located between the same parallel lines PQ and BC, and therefore they are equal to each other. But this angle equals to 90 degrees according to our construction, therefore this angle must be also equal to 90 degrees. Okay, so In the next step, we define the left of this line segment BN as x. So what is left of this line segment NC? From the drawing, it is very easy to see that NC equals to BC minus BN. So NC equals to BC, that is 21, minus BN, that is x, according to our definition. So in total, NC equals to 21 minus x. In the next step, I copied this right triangle A and B in an impingement. We implemented the Pythagoras theorem on this right triangle A and B. This is the right triangle A and B that according to the original drawing. According to the Pythagoras theorem, in this right triangle A and B, AB squared equals to BN squared plus AN squared. We subtract BN squared from this equation, equation 1. We finally found out that AN squared equals to AB squared minus BN squared. So AN squared equals to AB squared. AB is 10, therefore AB squared is 10 squared, that is 100 minus BN squared. BN is x, therefore BN squared is x squared. So in total, actually according to equation 1, we found out that AN squared equals to 100 minus x squared. In the next step, I copied this right triangle A and C in a new page and implemented the Pythagoras theorem in this right triangle A and C. This is the right triangle A and C that according to the original drawing. According to the Pythagoras theorem, this right triangle A and C, AC squared equals to AN squared plus NC squared. We subtracted NC squared from this equation, equation 2, and finally found out that AN squared equals to AC squared minus NC squared. So AN squared equals to AC squared. AC is 17, therefore AC squared is 17 squared, that is 289 minus NC squared. NC is 21 minus x, therefore NC squared is 21 minus x squared. So actually according to equation 1, we found out that AN squared equals to 289 minus 21 minus x squared. This is according to equation 2. But according to equation 1, we already found out that AN squared equals to 100 minus x squared. So here two different equations for the value of AN squared. Therefore, we can do equation 3 that says that AN squared according to equation 1 must be equal to AN squared according to equation 2. AN squared according to equation 1 equals to 100 minus x squared and must be equal to AN squared according to equation 2, that is equals to 289 minus 21 minus x squared. So according to equation 3, we actually found out that 100 minus x squared equals to 289 minus 21 minus x squared. We open the brackets of 21 minus x squared and found out actually that 21 minus x squared equals to 21 squared, that is 441, plus x squared minus 2 times 21 times x, that is minus 42x. So in the next step, we open the brackets on this side of equation 3. We found out actually that minus x squared equals to 289, and after we open the brackets, we get here minus 441 minus x squared, and we have minus times minus is plus, which will be plus 42x. So here we have x squared on both sides of this equation 3, therefore we have minus x squared on both sides of this equation 3, so minus x squared will get cancelled. After we cancel minus x squared, in this side of the equation we left only with 100, and the other side of the equation we left with 289 minus 441 plus 42x. So here we added 441 to this equation, equation 3, and we found out that 100 plus 441 is 541, and the other side of the equation we have with 289 plus 42x. Here we subtracted 289 from this equation, equation 3, and found out that 541 plus 289 equals to 252. So according to equation 3, 252 equals to 42x. Here we divided this equation, equation 3, by 42, and finally found out that x equals to 252 over 42 is 6. So x equals to 6 units in its length. In the next step, we return to equation 1. According to equation 1, we actually found out that an squared equals to 100 plus x squared. So an squared equals to 100, x is 6, therefore x squared is 36. So an squared equals to 100 plus x squared, and x squared is 36. So in total, actually found out that an squared equals to 100 minus 36, that is 64. An squared equals to 64, we took out all of this equation and found out that an equals to the square root of 64, that is 8. So here, an, this line segment an equals to 8 units inside, an equals to 8. In the next step, we define the width of this rectangle PQST as B and the length as A. So PQ equals to A and the width QS equals to B according to our definition. It is PQST is a rectangle. We know that all the angles inside a rectangle are right angles. Therefore, those two angles are right angles. There are 2 out of 4 angles of a rectangle PQST, therefore they are right angles. In the next step, we focus on this small quadrangle MQSN. Inside this small quadrangle MQSN, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle. In total, they must equal to 360 degrees according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its size. So inside the small quadrangle MQSN, we have 4 right angles, and according to rule 6, any quadrangle that has 4 right angles must be, it is a rectangle if not a square. So we relate to this small quadrangle MQSN as a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in the small rectangle MQSN, side QS must be equal to the opposite side MN, but QS is B, therefore MN must be also equal to B. What is the ref of AM? From the drawing, it is very easy to see that AM is total equals to AN minus MN. Repeat again, AM equals to AN minus MN. AN is 8 and MN is B. So in total, AM equals to 8 minus B. Those two angles, they are defined as corresponding angles and are located between the two parallel lines PQ and BC, and therefore they are equal to each other according to the rule that corresponding angles between parallel lines are equal to each other. So if we find the size of this angle is alpha, then this angle must be also equal to alpha because those two angles are equal to each other. Likewise, those two angles are also corresponding angles and are located between the same two parallel lines PQ and BC, and therefore they are also equal to each other. So if we define the size of this angle is beta, then this angle must be also equal to beta. In the next step, we proved that the big triangle ABC is similar to this small right triangle APQ. So, triangle ABC is similar to triangle APQ. First of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to beta, therefore they are equal to each other. And finally, this is angle A, this is a common angle that belongs to both triangles, so we can write down that angle A equals to itself as a common angle that belongs to both triangles. So actually proved that all the angles of the big triangle ABC are correspondingly equal to all the angles of the small triangle APQ, therefore those two triangles are similar to each other according to angle similarity rule. Actually found out that the big triangle ABC is similar to the small triangle APQ according to angle similarity rule. And whenever you have two triangles that are similar to each other, then the ratio between their corresponding heights must be equal to the ratio between corresponding sides. So here in our drawing, it means that the height AM in the small triangle APQ over the height AN in the big triangle ABC. Yeah. So the ratio between the height of the two similar triangles, that is AM over AN, must be equal to BC, that is the side of the small triangle APQ, over BC, that is the side of the big triangle ABC. So the ratio between their heights, that is AN over AN, must be equal to the ratio between their sides, that is PQ over BC. AM is 8 minus B, AN is 8. AM is 8 minus B, AN is 8. PQ is A according to our definition, it is the length of rectangle PQ is 10, BC is 21. Again, PQ is A and BC is 21. So actually, according to equation 1, we actually found out that 8 minus B over 8 equals to A over 21. Here, of course, multiply this equation, equation 1, and we found out that according to this equation, equation 1, 8A equals to 21. Inside the brackets, we have 8 minus B. Here we divided this equation 1 by 8, and finally found out that A equals to 21 over 8 times 8 minus B. Here we open the brackets on this side of this equation 1, and finally found out that A equals to 21 over 8 times 8 is 21, and 21 over 8 times 1 is 3, minus 21B over 8. So here we multiply this equation 1 by B, and finally found out that A times B equals to 21B minus 21B squared over 8. So what is A times B? A times B is the area of this rectangle PQST. Why? Because A is the length, B is the width, and the length times the width is the area of this rectangle PQST. So in equation 1, according to equation 1, the area of rectangle PQST, that is equals to A times B, equals to 21B minus 21B squared over 8. Actually, in equation 1, we have the area of rectangle PQST is function of B. B is the independent variable, and the area that is A times B is the dependent variable. Again, in equation 1, we have the area of rectangle PQST as function of the independent variable B. B is the width of this rectangle PQST according to our definition. Our mission is to find out the maximum area of this rectangle PQST. Or in other words, our mission is to find out the maximum value of the dependent variable A times B, because the area is A times B. So, for which B we get the maximum value of A times B, or we get the maximum area of rectangle PQST, that's actually A times B. In order to find out what is the maximum value of this function, that is function area of rectangle PQST, we have to differentiate this function area, and we have to equate the derivative to 0. In this way, we will find out extreme points in this function area, and then we have to draw the graph of this function area in order to find out whether if the extreme point that we found, it is minimum extreme point or maximum extreme point. Okay, so we started here by the first step, we differentiated this function area. This is a relation for derivative, so we took the derivative of this function area, that is actually 21b minus 21b squared over 8. And we equated this derivative to 0 in order to find out the extreme point of this function area, of this rectangle PQST. So what is the derivative of 21b? The derivative of 21b, we know that the derivative of b is 1, therefore we know that the derivative of 21b times b is 21 times 1, that is 21. And what is the derivative of this expression minus 21b squared over 8? We know that the derivative of b squared is 2b, and therefore the derivative of this expression in total will be equal to minus 21 over 8 times 2b, and it is equal to 0. Here we took 21 as a common factor out of those two expressions. So what is left from 21 after we took away 21 as a common factor? What is left is 1. And what is left from minus 21 b squared over 8 after we took from it 21 as a common. What is left from minus 21 times 2b over 8 after we took from it 21 as a common factor? What is left? It's actually minus 2b over 8, and it equals to 0. Here we divided this equation 2 by 21, and finally found out that according to this equation 1, 21 over 1 is 1, so in this side of the equation we have only with 1 minus 2b over 8, and here we have 0 over 21 is 0. So actually according to equation 2, we found out that 1 minus 2b over 8 equals to 0. Here we added 2b over 8 to this equation 2, and finally found out that 1 equals to 2b over 2. Here we divided both the numerator and the denominator of this expression by 2. We found out actually that 2b over 2 is b and 8 over 2 is 4. So in conclusion, actually found out that according to this equation 2, 1 equals to b over 4. Here we multiply this equation 2 by 4. And finally found out that b equals to 4. That is to say, the extreme point of this function area a times b equals to 21b minus 21b squared over 8. The extreme point is b equals to 4. Now we have to draw the graph of this function area in order to find out whether if b equals to 4 is a minimum extreme point or a maximum extreme point. Actually, this is the graph of the function area of this function ab equals to 21b minus 21b squared over 8. This graph means the area of rectangle PQST is function of b, the which b is the independent variable, and the area a times b is the dependent variable. Again, in the x-axis we have the value of b, that is the independent variable, and in the y-axis we have the area a times b of rectangle PQST, that is the dependent variable. And from the graph it is very easy to see that when b equals to 4, when b equals to 4, then the area is in its maximum value, that is actually a little bit above 40 square units. So in this way we reflect that the extreme point that we found b equals to 4, it is indeed maximum extreme point and not minimum extreme point. So actually the only thing that is left to do is to put the value of b equals to 4 inside this function area. A times b equals to 21b plus 21 over 8 times b squared. And we just have to substitute b by 4 in order to find out what is exactly the maximum area of rectangle PQST when b equals to 4. So we did it and found out that the area of rectangle PQST, that is a times b, equals to 21 times b. b is 4, so it is 21 times 4 minus 21 over 8 times b squared. Again, b is 4, therefore b squared is 4 squared, that is 16. So the area of rectangle PQST equals to 21 times 4, that is 84. And here we have 16 over 8 is 2, so in total this expression equals to 2 times minus 21, that is minus 42. So if I found out that the maximum area of rectangle PQST equals to 84 minus 42, that is 42. I repeat again, the maximum area of this rectangle PQST equals to 42 square units. Okay? And then actually calculated, we know that when the area of rectangle PQST equals to 42 square units. The width B is 4. What is the length? You can find out what is the length according to equation 1 that states that the length A equals to 21, 121 over 8 times B. And we just have to substitute B by 4 in order to find out what is the length of rectangle PQST when the width B is 4. We did it and found out that the length A equals to 21 minus 21 over 8 times 4. B is 4. So it is 21 minus, here we divided both the numerator and the denominator of this expression by 4. So in the numerator we left only with minus 21. And the denominator we have 8 over 4, that is 2. So in total the length of rectangle PQST when its area equals to 42 equals to 21 minus 21 over 2. Minus 21 over 2 is minus 10.5, and therefore the length A equals to 21 minus 10.5, that is 10.5. So when the area of this rectangle PQST equals to 42 square units, that is actually the maximum area of this rectangle PQST, then the width B is 4 and the length A is 10.5. And A times B, that is the area of this rectangle PQST. A times B equals to A is 10.5, B is 4, and therefore 10.5 times 4 is 42 square units. So the area of this rectangle PQST, or the maximum area of this rectangle PQST, equals to 42 square units. Okay, thank you very much.